So excited to come your way once again. My name is Nanaya Wedu. You can call me Sir Nana. In this lesson, we are continuing on binary operation. In our previous lesson, we've looked at the commutative property of binary operation. Ensure to subscribe to my YouTube channel. Watch all the videos so that you can follow the lesson as we go through it. Now, in this lesson, we want to continue on the commutative property while we look at some examples of commutative property, right? So we are going to consider number and algebra patterns, specifically commutative property, where we are looking at some examples of commutative property. So let's consider the first example. So the question says that a binary operation star defined on the set of real numbers R by x operation y is equal to x minus y plus 2xy. Now, A, we are to find 4 operation 3, and then we are to find 3 operation 4. Then after finding these two, the B, we are to determine whether or not the operation is commutative. So now let's consider a solution for this question. So the question says that the operation is x operation y to be equal to x minus y plus 2xy. And in our I, which is AI, we have to find 4 operation 3. So mind you, what this implies is that wherever we see our x, we want to replace it with our 4 in the operation. And wherever we see our y, we want to replace it with our 3 in the operation. So let's consider how we can solve this. So it means that we have 4 operation 3 to be equal to 4 minus 3 plus 2 multiplied by our x is 4 and our y is 3. So it means our 4 operation 3 will be equal to 4 minus 3 gives us 1. 2 multiplied by 4 gives us 8. 8 times 3 will give us 24. So our 4 operation 3 gives us 25. Now let's consider our II. So II, we have to find 3 operation 4. So what this implies is that wherever we see our x, we must replace it with 3 now. And wherever we see our y, we must replace it with 4 in the operation over here. Now, so that implies that we will have 3 operation 4 to be equal to 3 minus 4 plus 2 multiplied by 3 multiplied by 4. So we have 3 operation 4 to be equal to 3 minus 4 gives us negative 1, right? Then plus 2 multiplied by 3 gives us 6. 6 times 4 gives us 24. So it means that 3 operation 4 will give us 23. Now look at it very carefully. We've studied commutative property and realized that 4 operation 3 and 3 operation 4, if they are the same, then it means that the operation here should be commutative. So by example, we've been able to see that the operation here is not commutative because by example, this gives us 25 and this gives us 23. But we must consider that using variables, when you are asked to determine whether or not the operation is commutative, you must use variables. So let's look at that. So we'll say that for commutativity, x operation y is equal to y operation x. Now, where x and y belong to the set of the real number system, as have been indicated in the question. So now we want to check the first part, which is x operation y. So that means that gives us a normal one that we know in the question, which is x minus y plus 2xy. Now let's call this equation 1. And then we would have y operation x, where in this case we will have y minus x plus 2yx. We'll call this equation 2. Now we want to inspect equation 1 and equation 2 to see whether they are the same variables in. So realize that equation 1, the x is positive here, while equation 2, the x is negative here. Just by saying that the first one is positive and the second one is negative, we can conclude that since equation 1 is not equal to equation 2, then the operation star is not commutative. So when you are asked to go through the process of determining whether or not an operation is commutative, you must ensure that you use the variables to determine that by taking the first part and taking the second part and then comparing the two. Now let's consider another example. Here it says a binary operation star defined on a set of real numbers R on M operation N, which is equal to M plus N plus 2Mn. Now we have to find 6 operation 5 and 5 operation 6, and we have to determine whether or not the operation is commutative. So now let's consider a solution for this. Right, so in this question, we are given M operation N to be equal to M plus N plus 2Mn. Right, and we have to determine AI 6 operation 5. So as you all know, what we are supposed to do is that wherever we see M, we must replace it with a 6. And then wherever we see N, replace it with a 5 in the operation here. So it means that our 6 operation 5 becomes equal to 6 plus 5 plus 2 multiplied by 6 multiplied by 5. So our 6 operation 5 is equal to 6 plus 5 gives us 11 plus 2 multiplied by 6 gives us 12. 12 times 5 gives us 60. So our 6 operation 5 will give us 71. Now let's check for II, where we look at 5 operation 6. So in this case, what we are saying is that wherever we see our x, we must replace it with our 5. Wherever we see our y, we replace it with our 6 in the operation here. Right. So what would that give us? It means that we will have 5 operation 6 to be equal to 5 plus 6 plus 2 multiplied by 5 multiplied by 6. So it means our 5 operation 6 will give us 5 plus 6 gives us 11. Then 2 multiplied by 5 multiplied by 6 will give us 60. So our 5 operation 6 as well will give us 71. So by example, we see that 6 operation 5 and 5 operation 6 gives us the same value. So we have in our mind that the operation here is commutative. But this is by example. So we must show using variables. So let's show that using the real variables. So we can say that for commutativity, now here we have M operation N is equal to N operation M. Right, we can say that where M and N is a member of the real number system. Right, so we want to take the first part, which is the M operation N. And we know that that is M plus N plus 2Mn. Now let's call this equation 1. Then we'll take the other way around where we have N operation M. And then this will give us N plus M plus 2NM. We call it equation 2. Now we want to compare equation 1 and equation 2. So we realize that the M is positive here. The M is positive here. So that is okay. The N is positive here. The N is positive here. Right? Then we have 2Mn and we have 2NM. Remember that we said that when it comes to commutativity, multiplication is commutative under real numbers. So 2Mn and 2NM are the same. So we see that they are the same for equation 1 and equation 2. So we can conclude that since equation 1 is equal to equation 2, then the operation star is commutative. So in this lesson, we have basically considered 2 different examples under commutative property, where we've looked at how we can solve for the operation when we are given real numbers, and how we can be able to determine whether or not the operation is commutative. In our next lesson, we would look at another example on commutative property. See you in the next lesson.